I am Jay Prakash, lecturer of Computer Science and Engineering Department, Government Polytechnic for Women. So let us start the fourth session of Computer Organization of Unit 2, Machine Instruction and Programs. So instruction execution and straight line sequencing. So the program is executed as follows. Initially, the address of the first instruction is loaded into the PC. PC is nothing but the program counter. It shows the next instruction to be executed. So initially, the program counter points to the first instruction to be executed. Then the processor control circuit uses the information in the program control to fetch and execute the instruction. So after the PC points to the particular location of the instruction is get fetched one at a time in the order of increasing address. This is called as straight line sequencing. During the execution of each instruction, the program counter is incremented by 4 bits to point to the next instruction. So there are two phases of instruction execution. One is the fetch phase, another one is the execution phase. In the case of fetch phase, the instruction is fetched from the memory location and placed into the IR. So fetch phase is nothing but reading the data from the particular location and placing into the instruction registers. Execution phase. The contents of the IR is examined to determine which operation is to be performed. So the execution phase executes the data. The specified operation is then performed by the processor. So after locating the operation will be performed and execution will be taken place. So let us take an example how the two variables, the operands A and B is added and will move to the C. So here is an example how the data can be added. Consider the program for adding a list of n numbers. The address of the memory locations containing the n numbers are symbolically given as num1 and num2. Okay, number 1 and num2. So the first number is located at the location I and the second number is located at the location I plus 4. Like this, it will get increased. Okay, the location address will be get increased. Separate the add instruction is used to each number to the contents of R0. So here, move the data of R0. So R0 is a register. So after all the numbers has been added, then the result is placed in the memory location sum. So here R0. So the number 1 will be moved to the location R0 and num2 later the num2 will be added to the data of the num1 and then the result will be stored in the finally the result will be stored in the r0 and it will be moved to the sum. This is how the operation will occur. So the operation of adding of the two numbers a and b and the result will be moved to the c. Initially it is represented to the location I and then the 4 bytes will be increased I plus 4. Like this the operation will continue. So initially r0 from A it will be moved to the R0 and then whatever the data that is present in the R0 will be added to the B and then finally move the data from the R0 to the C. So this is how the addition of two operation occurs, a straight line program for adding the numbers. So branching. Sometimes it is necessary that we we need to execute the process or execute the instruction at a different location, not a continuous sequence. So branching is required. Consider the task of adding a list of n numbers. The number of entries in the list n is stored in the memory location n. So that is the list. The register R1 is used as a counter to determine the number of times the loop is executed. So R1 mentions the number of times the loop executes. The content location n is loaded into register R1 at the beginning of the program. The loop is a straight line sequence of instructions executed as many times as needed. So how many times you can execute, that is the loop will be occurred. The loop starts as a location loop and ends at the instruction branch 0. During each pass, the address of the next list entry is determined and the entry is fetched and added to R0. Instruction decrement R1 reduces the content of R1 by 1 each time through the loop. Then the branch instruction loads a new value to the program counter. As a result, the processor fetches and executes the instruction, this new address line called as branch target. So the address location where the data need to be fetched is pointed out and from that location the data will be fetched. A conditional branch causes a branch only if a specified condition is satisfied. In the case of conditional branching, we are going to specify the condition where it needs to be executed. If the condition is not satisfied, the PC is incremented in normal way and the next instruction in the sequential order is fetched. So in the case of branching, we can shift from one location to another location. And in the case of conditional branching, based upon the condition we are going to branch to the particular location. Whereas in the normal way, it is a sequential order. Okay. Conditional codes. So what are the different operations that occurs in the conditional codes? The processor keep track of the information about the results of various operations. This is accomplished by recording the required information in the individual bits called conditional code flags. So conditional code flag refers what is the value that is present for the particular condition. These flags are grouped together in a special processor register called conditional code register. So conditional code register stores a value. Okay. For example, four commonly used flags are first capital N. If the N value is 1, so if the result is negative, if the value of the N bit is 1, then the result is negative. If the value of the N bit is 0, then the result is positive. Next, Z. Z is set to 1 if the result is 0, otherwise it is clear to 0. Overflow. Overflow is set to 1 if the arithmetic overflow occurs, otherwise if the value is clear to 0. Then the C. C is set for carry to set 1. The carry results from the operation, otherwise it will be clear to 0. So this is how the operations will occur. Next one is addressing modes. So in order to access a particular data, we need a address in order to find out the location of the particular data. So there are different methods to accessing the data. So the following are the different addressing mode. The first one is immediate addressing mode. In this case, the operand and value. The value will be directly assigned to the operand. That's why it is referred as immediate addressing mode. In the case of registers, so first the data will be moved to the registers. Whatever the input data you supply, it will be moved to the register. From the data, from the register, it will be moved to the particular location. In the case of absolute direct, so in the case of absolute direct, the location is mentioned directly. From the location, the data will be moved to the particular location. So indirect. In the case of indirect, instead of going to the particular location directly, we will refer to that location by another registers. Here, RI is the register location which should point to the particular address. From the RI, again from the location, it will be moved to the location. From the location, it will move to the particular address or particular location. So this is how the data will be moved. So instead of moving directly from the particular location, we move via other registers. In the case of index, index is the index adds the relative location. For example, if you are if you are at one location, then additional index will be get added to find out the path for that particular location. The basis with index. So examples, if there are two things, for example, Ri and Rj. So we are adding the contents of the register Ri and adding the content of the register Rj, that will be moved to the base. Next, x of Ri comma Rj. So here the base with index and the offset. Here Ri and Rj are added and then with the offset distance. In the relative, the case of relative, the program counter. So program counter points to the particular location where we need to execute the data. So along with the relative address, we can move the data to the particular location. Auto increment. Auto increment adds for the registers, it will increment the data, whereas in the case of auto decrement, it will decrement the registers. So this is how the different addressing modes works. So how the implementations of variables and constants will occur. What is variable? Variable is the memory location which holds the value. Okay, the value of the particular variable can be changed, whereas the value of the constants cannot be changed. Constants have a particular number which cannot be changed permanently. Okay, then the value can be changed as needed using the appropriate instructions. So there are two accessing modes to access the variables. So variables already told, it is the memory location where the data is going to get stored. In order to access the data from the variables, we can go for two methods. One is the register mode, another one is the absolute mode. In the case of register mode, the operand is in the contents of the registers. So whatever the data that is present in the register will be moved. The name and address of the register is given in the instruction. Whatever the registers that is mentioned, it will be moved to the particular register. Okay, and registers are temporary storage locations where the data is in the registers are accessed. For example, here move R1, R2. We move the contents of the register R1 into the register R2 by using the command move. In the case of absolute direct mode, the operand is in the memory location. The address of the memory location given explicitly in the instructions. Okay. So in the case of direct, we're going to move the data directly from that particular location. The absolute mode can be represented global variables in the program. For example, move the data from the location to the R2. Here, the content of the location LOC is moved to the data register R2. In the case of immediate mode, the operand is given explicitly in the instructions. For examples, move #200, R0. So here the value 200 is directly placed in the register or not. This is how the immediate mode will work. Okay. Thank you.